Hey everyone, and welcome to Dr. Abu RTN Academy channel. Today we are going to discuss part 7 of the sets and the probability in the subject of biostatistics. We stopped in the last video at the probability of the sum of two events, which called addition rule. So we are adding two events together. If I want the probability of event A plus the probability of event B, probability of A and B together, this is called like the probability of A union B. If you remember, we said this equals probability of A plus probability of B. This is what we have mentioned in the last video, but we said there is one condition has to happen in order to validate this formula. In order to say that the probability of A union B equals the probability of A plus the probability of B, probability of A plus the probability of B, we must have one condition, that the two sets must be disjoint, like these two sets. See here, there is no intersection. They are disjoint. A is separate and B is separate. Okay, so A separate set and B separate set. So in this case, we can say it's equals A plus B. But if there is intersection between them, like this one, so if we say the probability of A, so we get all A, okay? And the probability of B, we get all B, including again this part or this section of A, which was already counted. So it's counted twice. So we have to say the probability, if there is, in the case of the disjoint, this formula can be applied, okay? But in the case of not disjoints or we have intersection, okay? So in this case, the probability of A union B, or you can call it A plus B, probability of A plus the probability of B, it is the same. Plus means union, okay? So it will be equals probability of A plus probability of B, also same as here, okay? Probability of A plus probability minus one time the overlap, which is probability of A intersect B, okay? Not union, here intersect, okay? The intersection, this area, which is the intersection, because it has been already counted one time with A, we cannot count it again with B, okay? So it will be probability A plus probability B minus the intersection. And if there is no intersection, this is the general formula. If you remember, this is the general formula of the union of the probability of union of two sets. If the A and the B are not intersecting, so this will be equaling 0. Probability of A intersect B will be equal to 0, so it will be probability of A plus probability of B, okay? So this is the general form, can be used for anything, okay? So let us come here and read what's written. Okay, just let us clear this one, so we can go through it again on a clear page. So here it is written probability of A plus B. We said A plus B means A union B equal probability of A plus probability of B. Only true for mutually exclusive event. Mutually exclusive events means disjoint. Like this one, disjointing. This one is exclusive, independent. This one exclusive is independent. So both of them mutually means all of them or two of them or both of them. All of them are independent. So this one and this one mutually exclusive. Each one of them are exclusive, independent, okay? In other cases, probability of A, where we have intersection, so probability of A plus B will be equal to probability of A plus probability of B, which is general form, minus the probability of A intersect B. This can be written because intersection, it happens only if A and B together happening here. So it's called probability A, B together. So probability of A and B happening together here in this area, A and B happening together. So if you find A, B means A intersect B. Some books are writing it A intersect B, and some books are writing it A B, like Debrecen University. They're using this way of writing it. So it's here stated as A B. A B means A and B happening together, which is the intersection of A and B. Okay. So it will be the probability of A plus probability of B minus the probability of A intersect B. Okay, which called A and B, A, B together. Okay, A, B happening only here together. Otherwise, if we did not subtract this one, we would count the intersection twice. It will be counted with B and it will be counted with A. That's why we are subtracting it here. In the conditional probability, we have the probability of an event, okay, subject to or with the condition that another probability has already happened. It's already given that something happened and done. So it's given that it has happened already. So we are sure that this given thing already happened. So what is the probability of the other thing? So conditional probability is the probability of an event A given the occurrence of another event B. So I want to calculate or to find the probability of event A, but I knew that probability B has already happened, which of course it will be linked or related to probability A. So it is not only the probability of happening of event A, no, probability of happening of event A, but given that something else already happened. So we have to take into consideration that it's already done, it's already happened, given the occurrence of another event B. That's it. It gives the probability that A will occur under the condition that B does occur, okay? Has happened, okay? Notation, how we write it, the notation of it, we will write it probability of A and straight line given B. This means the probability of happening of A given that B has already happened. Okay, so as we can see here, down here, the probability of B happening, that B happens, given this line, given that the event A already happened. So the last one means the given one, which already happened. This should be the last one. After the given line, the second one, the thing which already happened, which we knew and sure that it's already happened. So what I'm looking for, the first one, the probability of B. That's what I'm looking for. Probability B, that's what I want to find. The first one. Given that A already happened, and we have to be careful. In the previous example, we have probability A given that B happened, which is different than probability of B given that A happened. This is the other way around. So in the conditional probability, the order matters. The order for conditional probability notation, the order matters. Okay, which one comes first? This is the one which I want to calculate, which I want to find. And after the given line, the one which is already given to us. So, luckily, the formula of the conditional probability is easy to memorize. So, the probability, if we look here down at this box, here, the conditional probability formula, the probability of A. So keep in mind that what we want to find is the first one, the probability of A. This is the one which we are looking for, given that B is given. Okay, so the probability of A given B already happened. Okay, so the probability of A given that B already occurred. Okay. So probability of A given B equals the probability of the first one, A, intersect B. probability of A intersect B divided the given one. The probability of A intersect B divided the probability of B. Okay? Okay. So probability of A given B equals probability of A intersect B divided probability of the second one B. Again, probability of A given B equals the probability of A, just both intersect, probability of A intersect B, okay, but we have to add probability P, okay. It is not the elements of the set. That the probability 0.1, 0.2, 0.5, 0.7 from 0 to 1. Okay, it is the probability itself. It is not the elements 1, 2, 3, 4, 5, 7, 17, black, red, up, down. No, it is the probability. Okay, so all what we want, what we have to do here, if we find the probability of A given B, just to convert it, we say probability of A intersect B, just convert this to intersect, okay, divided probability of the one after given, probability of B, that's it. Okay, some people writing, as we mentioned the last slide, A intersect B, they're writing AB. So which means A and B both together are happening. A intersect B also means that A and B, both of them are happening in this area. So A and B means the probability of A and B happening. So it is the same. A intersect B or AB, it is the same thing. Here in Debrecen they're using AB, but most of the books are A intersect B. So the formula is probability of A given B equals probability of A intersect B, just add intersect, divided this one, probability of B. So if we look at this new formula here, so we'll find the probability of A given B equals the probability of A intersect B divided the last one. Okay, so we can have also cross multiplication if we cross multiply this. So it will be like divided one, this multiply this, and this multiply this. Okay, so we'll have the probability of A given B equals, probability of A given B times probability of B equals probability of A intersect B. So we can have it in a different way. So this is the main formula. Okay, this is the main formula, but we can use the derived formula which we have now through the cross multiplication for future calculation or finding the probability of any intersection. So the probability, how to memorize this, the probability of A intersect B, okay, equal the probability of A, we can replace intersect by given, probability of A given B times the last one, times the probability of B. So if I say the probability of B intersect A, okay, I can say equal the probability of B given A, just replace intersect by given times the probability of A, the last one. Okay, so it is valid. So now we can memorize this one. So here the probability of A given B equal the probability of A intersect B, okay, divided the probability of B. If we have cross multiplication, probability of A given B, this is different way of just typing or writing it, equal the probability of B intersect A, and actually I have given this example just to remind you that intersection A intersect B, it is same as B intersect A. Not given. Given, no. Given, the order matter. Given, in the given problem, the order matter. But the normal intersect, A intersect B, it will be A. Intersect B, it will be this area. B intersect A, it will be the same area. This is just the intersection. So I can write A intersect B or B intersect A. It doesn't matter, okay? But in the given, it matters. In the given here, it matters. So A given B, it is not equal to B given A. So here we can write this one, the probability of B given A, okay, equal the probability of B intersect A, this one, or A intersect B, it doesn't matter, divided the probability of the last one, okay, divided the probability of the last one. Here also, the probability of A given B, the probability of A intersect B, divide the probability of the last one. So the one in the denominator, always the last one, the given one, okay? And also, as I have given here in this example, okay, as I have given here in this example, I can, from the cross multiplication, say the probability of A intersect B equal the probability of A given, okay, probability of A given B times the probability of A given B times the probability of B. Okay, so the probability of A intersect B equals the probability of A. I can replace intersect by given probability of A given B, A, B, and just replace the intersect by given B, multiply or times probability of the second one of B. Okay, I hope this one also is clear. In the same way, I can write it the probability of A intersect B, because A intersect B or A, it doesn't matter, because here, this one also, A intersect B, it can be written as probability of B intersect A, right? So if we wrote it in this way, it will be the probability of probability of B given A times probability of A. The thing which you have to notice that the last one here, the given is A, and always it's multiplied by the same thing. So A, it will be here A. If it is B, it will be B here, okay? So it will be this one. Why? Because it is also the probability of B intersect A. B intersect A, oh yeah, became very messy, so just let us clear it, okay? So probability of A intersect B equals the probability of B intersect A. This is not given, this is intersect, okay? So in this case, I can say the probability of A intersect B equals this one. The probability of A, about A intersect, I replace it by given B as it is, times probability of B. If I use the alternative one, the probability of A intersect B equals the probability of B intersect A, we can get the probability of B, okay, given, instead of intersect, given A times the probability of A, okay? He has got this, the last formula here from these two formulas. So from here, he got the first one, and from here he got the second one, okay? But it is the same, because intersect A intersect B is equals to B intersect A. But the way we need to memorize it, we say that probability of B intersect A equals the probability of B. I replace intersect by given A times probability of A. That's it. If I want the probability of A intersect B, it's very easy. Probability of A, instead of intersect, given B times probability of B. I think it's easy even to memorize. So if we now look at the definition which we have there in the Debrecen slides, the conditional probability is the probability of event A given occurrence of another event B. That's it. That is It gives the probability that A will occur under the condition that B does already occur, okay? That B already does occur, okay? In notation, as we mentioned, the notation, probability of A given B reads as probability of A given B. If A and B are two events, okay, and probability of B greater than 0, because the probability of anything A or B or anything is greater than or equal to 0 and less than or equal to 1. It cannot be more than 1, cannot be less than 0. So always the probability should be greater than 0, but it could be equals to 0. But in this case, we have probability B, the given will be in the denominator. If the denominator is 0, this means infinity. We cannot have any denominator in the world with the value 0. That's why it's mentioned here, if A and B are two events, and the probability B, why B especially? Because B would be in the denominator. If A is in the denominator, it will be probability A greater than 0. Why greater? Because in all the cases it must be greater than or equals to. So here just in order to exclude equal to. So probability of B is greater only, not greater or equal, no, greater only. Okay, greater than 0. So we'll exclude that the probability of B will be equal to 0 because it is in the denominator, and the denominator cannot have 0 value. Okay, the value of it cannot be 0. Then the probability of A given B, it will be equal to the probability of A intersect B. Here it is written as P, probability AB. We said probability AB means probability of A intersect B. It is written as probability AB. So probability AB means A and B happening at the same time, which is this area. Probability AB, okay? You can memorize it A intersect B or AB as you like, but it is this area at the end of the day, okay? Divided the last one, the probability B. Rearranging the formula as we have taken in the previous example which I have given, rearranging the formula, so we can have the probability of B, probability of A intersect B, which is AB, probability of AB, it is the same. We just mentioned this now. Probability of A intersect B equals probability of A given B times the probability of B. Okay? Also, if we mention this one, probability of AB intersect A, so it will be probability of B given A times probability of B, which is this one. Okay? So don't scare or don't worry that we have the two things, because probability AB means, let me clear this one, so write it in a clear area. So this one means probability A intersect B, and also it is probability B intersect A, because both of them are the same. As far as it's intersect, both of them are the same. Okay? Okay, so we can write any of this formula. So if you find probability AB together, means A intersect A intersect B. Probability BA, it is the same thing. Probability of B intersect A. So all these four are the same. Probability A intersect B, B intersect A, AB, because AB, it means A intersect B. Probability BA equals this one. So in an easy or a simple way, you can write probability A intersect B, probability A, replace this intersect by given B, then times probability of B. That's it. If you want to use this example, you can write probability A, just put between them, put dash or the line here between them. Probability A given B times probability B. Okay, so this is the form, and the same thing also here. Probability, you can put B, then put line here. Okay, A, put it here. Okay, times probability A. The last one, the given one, always it has to be multiplied. Its probability has to be multiplied by that. So the multiplication here by the probability of the given one. Okay, I hope this one is clear. And I, as you can see here, is the universal set. Okay, so the probability of the universal set, we said it's always 1. So probability I in Debrecen slides equals 1, which is a universal set. Okay, so now coming to this example on the conditional probability, in order to understand how the example or how the problems comes in the exam. So they're repeating here, the probability of A given B equals the probability of A intersect B or AB together divided the probability of B. Okay, we have the example here, set A, open the brackets of the set, the parentheses of the set, okay, equals here by the description. They did not list down the element, just to give us the description. Okay, the first year student at general medicine. Okay, and set B, the Norwegian students at general medicine. Okay, so the probability, this is A, which is first year. So these are first year students. And this group B or set B is Norwegian students. Okay, so the probability of set A or event A means that there will be the first year students, this one, the first year students, the probability is 0.24 for the whole set A, that will be first year student is 24% or 0.24. The probability of being a Norwegian students, it is set B. Okay, it will be set B. Okay, this is the probability, it will be Norwegian student. The probability of them is 0.05. So what is the probability of being students at the first year and at the same time they are Norwegian students? Of course, it will be less than the probability A and less than the probability B. Okay, because probability A is a big set, probability B is a big set, and this is portion of both of them. So it will be 0 point something, which is lesser than this and lesser than this one. In the example here, he give it as 0.015. So here they have given us the probability of event A, probability of event B, and the probability of the intersection AB. Okay, so the question here, what is the fraction? I want you to fully concentrate in this point. Once you get it, it will be easy. Nothing will be problem for you in the conditional probability and the given probability problem. Okay, so what is the fraction of the first year students is Norwegian? So I'll just teach you how to read this question in order to understand what he's looking for and what is the given. This is the point here. If you can identify what is the given and what is he's looking for, so it will be easy to solve it. So let us read it in a different way. What is the fraction? Okay, what is the fraction? Is Norwegian. This is what he's looking for. The fraction of Norwegian. So we said this is the probability of A. This is what I'm looking for. Probability of A. Given that B. So here, what is the fraction of Norwegian? Given that, okay, so what is the fraction? He's looking for the fraction of the Norwegian people, students. Okay, and he gave us this one. What is the fraction of the first year? So this is not subject of discussion. We are not discussing this one. We are not calculating it. He said the fraction of the first year. So this is given to us. The first year is given to us. So what is the fraction of the first year? Is Norwegian. So the question, what is the fraction? Is Norwegian. So this is, what is the probability of A? What is the fraction of Norwegian? Okay, given that B happened or occurred. So what is the fraction is Norwegian of the first year? So first year, it is not part of it is given. Okay, so in this case, what is the fraction is Norwegian? So he's looking for whom? For Norwegian. So he wants the probability of whom? Of the Norwegian. The Norwegian is B. So he wants the probability of B, and given that they are in the first year. Okay, it is given that what is the fraction of the first year is Norwegian. So this is given, okay, that they are in the first year. First year is set A. So probability of B, A, given A. Probability of B given A, not A given B. The order matters. So it equals probability of BA divided probability of the last one, the given one, probability of A. We can write it the probability of B intersect A divided the probability of A. Okay, you will find this in most of the books, but here in Debrecen they're using this way or a notation. Okay, so in order to be aligned with the example, so I'm using the same notation. Okay, so it will be probability of B A divided the probability of. So what is the probability of BA? Probability of BA, it is same as the probability of AB. Okay, so here the probability of B given A. So now I hope that you understand how we are writing, how we are identifying whether the probability of B given A or A given B. This is the key point. If you miss that, you will your answers will be incorrect. Okay, so it will be the probability. Don't surprise it is AB. It's BA or AB. A intersect B or B intersect A, it doesn't matter because it's an intersect at the end of the day. Okay, I hope this one is clear. Okay, so A, B or BA, if it's intersect, doesn't matter. Only in the given it matters. Okay, the probability of BA or AB, which is 0.015 equals 0.015 divided the probability of A, which is 24. So it would be equals 0.0625. If I want to get it as a percentage, it would be 6 times 100. It would be 62.5%. Okay, this is the probability of the first year students Norwegian. So if he asks the question in a different way, what is the fraction? Here actually it should be 625 over 1000. Okay, because he asked about the fraction. So this is a fraction, not percentage, okay, or decimal. But anyway, all of them are right, but it depends on the question itself. So what is the fraction of the Norwegian students in the first year? So here in this problem, so what is the fraction is in year one. So we can read it this way. What is he's looking for? As we said here, he's looking for this one, the probability of A. So this is the probability which he's looking for, probability of A. So what is the probability of A? What is the fraction or the probability of first year? So I can write the probability of first year. What is first year here? First year is A, probability of A. And he has given me that they are Norwegian. What's the fraction of Norwegian students? So it's given that they are Norwegian. So given that B is given. So the probability of A given B equals probability of AB, which is BA or AB because this is intersect, divided the probability of the last one, probability of B. So it will be equals the probability of AB or BA, which is 0.015, divided probability of B, which is 0.05, which equals 0.3 or 30%, or 3 divided 10. Okay, I hope that this one also is clear.